say the
Okay, so myself P.R. Kharade, I'm working as an assistant professor in the Department of Chemistry, KH College Galwadi. This is my contact number. You can take this contact number for further. Okay, so today we will discuss the electromotive force, this electromotive force topic. BSc 3 CBCS Physical Chemistry. We are in semester number 5, and as discussed yesterday, the paper number 11 for the physical chemistry. The code number is DSC E7. So we'll move next slide. So while discussing the introduction, we know that when a chemical reaction occurs, there will be the transfer of electrons from one substance to other. So this is one substance, and this is another substance. When the reaction occurs between these 2 points, the flow of electrons take place from this point to this point. Okay, so this movement of electrons can be harnessed to do electrical work. What is meant by the harnessed? Harness means harness means to join for work. Okay, so simply the harness means to get use of them. Okay, so this movement of electrons from one substance to another substance, this can be utilized for the electrical work. We know that when electrical work, when we'll get electrical work, when there is flow of electrons. Okay, is it right? So this movement of electrons can be used to carry out the electrical work. The next is EMF measurements of cells can be interpreted in terms of thermodynamic characteristics of the cell. That means EMF, it can be related with the thermodynamic some characteristics. Next is EMF measurements can be used to predict variety of thermodynamic parameters. The first one is the equilibrium constants of variety of reactions. When if we will measure the EMF of cell, we can calculate the equilibrium constant of a reaction. Then by measuring the EMF value, we can calculate the pH of solutions. Suppose a solution is given to you and you are asked to calculate its pH or to determine its pH, then you have to measure its EMF, and by using the formula, you can easily calculate the pH of solution. The third is solubility of sparingly soluble salt. There are different sparingly soluble salts available with us, and by measuring the EMF, we can calculate the solubility of such sparingly soluble salts. The next is fourth one is gives free energy change. If we measure the EMF, we can easily calculate the delta G. Delta G, it is known as free energy change. If you have notebook, you can get these terms in your notebook. You can take it down. The fifth point is enthalpy change, that is delta H. Delta H means enthalpy change. So this delta H can also be calculated by using the EMF measurements. And the lastly is entropy change, that is delta S, change in entropy. Here the change in enthalpy and here the change in entropy. So these are the 5 parameters we can calculate by using EMF measurements. Okay, so this is some introductory point. We'll go to the next slide. Now, after the introduction, we will discuss some basic terms of electrochemistry. Okay, so the word electrochemistry generally give us information about chemistry of electricity. You can take this like this chemistry of electricity. It is the electrochemistry. So uh, definition is electrochemistry is the branch of physical chemistry which deals with the energy changes. Okay, so you can easily understand what is meant by electrochemistry. It is the branch of physical chemistry which deals with the energy changes. Then what types of energy changes? What type of energy changes? Chemical energy is converted into electrical energy. This is one energy change. That means we are converting chemical energy associated with chemical compounds into the electrical energy. Okay, and the next energy change is electrical energy is converted into the chemical energy. That is, it means that by the use of electrical energy we can carry out the chemical reaction. Okay, so for this conversion, that means if we have to convert chemical energy into electrical energy or electrical energy into chemical energy, the device usually is called as electrochemical cell. Okay, so the electrochemical cell, it is the only device used for the energy conversion. That is from chemical energy into electrical energy and electrical energy into chemical energy. Then what is meant by this electrochemical cell? It consists of a pair of electrodes dipped into an ionic or electrolytic solution and connected by an external metallic wire. So the electrochemical cell simply, wait, I will take a new color. So this electrochemical cell, it consists of a pair of electrodes. That means two electrodes are there. Two electrodes, that is pair of electrodes. These two electrodes are dipped into an ionic solution. The solution must be ionic or electrolytic solution. Electrolytic means the solution of electrolytes. And you have to connect these these two electrodes by an external metallic wire. I request all the students don't make noise. I request all the students don't make noise. Other students are listening this lecture. Okay, so understood this electrochemical cell. The cell, now the two terms are there. The cell, or you can say the electrochemical cell, that converts, this is important, electrical energy into chemical energy is known as electrolytic cell. Okay, the electrochemical cell which converts electrical energy, that is by using the electrical energy, chemical energy obtained, this can be achieved by using the electrolytic cell. Okay, and the other type of electrochemical cell, it converts the chemical energy into the electrical energy, and this, it is also called as voltaic or galvanic cell. Okay, so these are the two types of electrochemical cells. One is electrolytic cell and the other is voltaic or galvanic cell. Okay, we'll see. So in this slide, you will easily understand the structure. So a simple electrochemical cell, in previous slide it is told there are two electrodes. This is one electrode, this is another electrode. Okay, and this is ionic solution, or it is electrolytic solutions. Okay, and these two electrodes are connected by this external wire. So this is simple electrochemical cell. And now this is electrolytic cell, okay, and this is voltaic or galvanic cell. Here the electrical energy is converted into chemical energy, and in this the chemical energy is converted into electrical energy. Okay, so you can easily understand the electrochemical cell. Electrochemical cell. Okay, by using this slide. Okay, then in the next slide, we'll discuss the Daniel cell, a simple galvanic cell. So this is used to convert the chemical energy into electrical energy. Okay. So what is this Daniel cell or galvanic cell? It consists of zinc rod immersed in zinc sulfate solution in one compartment and copper rod immersed in aqueous solution of copper sulfate in another compartment. That means you have to take two compartments. This is one compartment and this is other compartment. Here you have to use the zinc rod. Here you have to use the copper rod. Here you have to take the zinc sulfate solution and here you have to take the copper sulfate solution. Okay, and the two compartments are connected by a salt bridge for a purpose of transfer of ions. So if you look the previous slide, okay, so this is actually the voltaic or galvanic cell. Okay, so here silver electrode is used. So this is about the Daniel or galvanic cell. On connecting the electrodes externally by metallic wire, the cell starts to operate the following reactions. Means once we connect the electrodes, following reactions occur. Which reactions occur? First one is the oxidation at zinc electrode. So at this electrode, that is zinc electrode, oxidation occurs. Oxidation. So zinc in solid state undergo oxidation to give zinc 2 plus ions and 2 electrons. It liberates 2 electrons. And reduction at copper, this is copper electrode. Okay, wait, I will change the color. Okay, so this is copper electrode, copper and copper sulfate solution. So reduction at copper, at this copper electrode, the reduction occurs. The copper 2 plus ions present in the solution, they take the 2 electrons lost by the zinc rod or zinc compartment and it forms the solid copper rod. So the overall reaction is the sum of these two reactions, that is zinc solid plus copper 2 plus ions. It gives zinc 2 plus ions plus copper solid. So this is the overall reaction of this cell. So here the transfer of electrons from one compartment to the other compartment have taken place. You can easily understood. Okay. Then the next term is electrode. It is important. An electronic conductor, it may be graphite or metal, it is called as electrode. Okay. So zinc and copper rods are used as electrodes in Daniel cell. It is very simple. The third is half cell. Half cell, an electrode in contact with electrolytic solution constitutes the half cell. That means in one compartment we have taken the zinc rod and zinc sulfate solution. So this is called as the zinc half cell. So zinc in zinc sulfate, it is zinc half cell, and copper in copper sulfate, it is copper half cell. Half cell is generally called as electrode. Okay, so this you can call as electrode, that is zinc in contact with zinc sulfate solution. This is termed as electrode or half cell. The next very simple definition or term is oxidation and reduction. Oxidation, it is the process of loss of electron. Okay, so in zinc solid, it forms zinc 2 plus ions, it gives 2 electrons. So 2 electrons are lost, hence the zinc undergo the oxidation process. Okay, and reduction process, reduction is the process of gain of electrons. That means the copper 2 plus ions take the 2 electrons, it gives the copper solid. So this copper have gained these 2 electrons, hence it had undergone this reduction process. Then fifth is anode and cathode. An electrode at which oxidation occurs, here the oxidation is important and here A is capital. So you can easily understand the electrode at which oxidation occurs is called as the anode, and an electrode at which the reduction occurs is called as cathode. So here C capital is there. So at cathode reduction occurs and at anode the oxidation occurs. So zinc is anode because it has undergone the oxidation, and copper is cathode because it has undergone the reduction in Daniel's cell. 6. Half cell reaction and cell reaction. Reaction occurring in half cell is known as half cell reaction. That means in one compartment the zinc undergo oxidation, zinc 2 plus 2 electrons. This is half cell reaction, and half cell reaction is also called as electrode reaction. Okay, and the cell reaction is the sum of two half cells reactions. Okay, and the last point is representation of cell. According to IPSC, that is International Union of Pure and Applied Chemistry, the following conventions are used to represent the cell on paper. So first is anode, that is negative electrode is written on left side. This is important. And cathode, that is positive electrode, is on the right. That means whatever the negative electrode, that is anode, it is at, this is left side. So on the left side you have to write the anode, and this is right side. Okay, so here you have to write the cathode, that is electrode, cathode electrode. Then B is double vertical line indicates the use of salt bridge or porous spot to eliminate liquid junction potential. So whenever you find like this, so this is the use of salt bridge. The double vertical line indicates the use of salt bridge. Okay, and the single vertical lines represents the phase boundary. Okay, so whenever you found this single line, so it is called as the phase boundary. Okay, so anode is represented as this electrode and electrolytic solution. This represents phase boundary, that is anode, it is negative, that's why this is negative, left hand side. And cathode is represented as electrolytic solution and electrode. So this is as this is cathode, it is written on the right hand side. Okay, so the complete cell can be written like this. Wait, I will erase this plus. Okay, so complete cell, how can it be written? So this anode is written as this electrode, this phase boundary, electrolyte solution, and here double vertical line, that means use of salt bridge. Again another electrolyte solution and phase boundary and other electrode, that is cathode. This is cathode as it is written on the right side, and this is anode, negative electrode, because it is written on left side. Okay, so